Today's lesson, we're going to learn how to draw isomers of simple organic compounds. The types of isomers that we're going to discuss today are called structural isomers, or also they could be called constitutional isomers. And constitutional isomers differ in how atoms are connected, and we're going to look at some examples at how that, or what that actually means. They also have different physical and chemical properties. So here we have isomers of butane. One of the isomers is just the straight chain with the 4 carbons. The other isomer, you can see that we've taken one of the CH3 groups off of the end, and we've put it on one of the internal carbons. And that gives us the isomer 2-methylbutane. The CH3 group becomes an alkyl group off of the CH, or that central carbon, and we call it 2-methylbutane. Now, I would like you to take note of the boiling points and the melting points for both of these. You can see that the boiling points are different and the melting points are different. They don't differ by a whole lot, but they do differ. So isomers do have different physical properties, and they also do have different chemical properties. Also, the names will be different. When we write isomers of these long carbon chains, the names of all the isomers should be different. So one way to check that you don't have the same isomer written or drawn is by naming them. We're going to practice with hexane, and we're going to look at the rules that we would follow, or the steps that we would follow to draw the structural isomers. So the first step that you want to do is draw the continuous straight chain for hexane, or C6H14. Then you will try 5 carbon structures with methyl groups attached, like you saw with butane, and then you will consider 4 carbon structures that have 2 methyl groups. So we're going to follow those steps to draw all of the structural isomers for hexane. So the first step is to draw this straight continuous chain of hexane, which you see I have drawn here. Now the next step is to take a methyl group off of the end and start to put it on those internal carbons and name them so that we make sure we don't have any duplicates. So I'm going to draw the first compound. We're going to make the carbon chain shorter by 1 carbon, so we're going down to 5 carbons, and we're going to take that 6th carbon that we took off the end, and we're going to place it on the internal carbon. And when we go to name this, this would be 2-methylpentane. And I didn't name this one up here, but we all know that this is hexane. You can see in the next structure that I drew that I took that same methyl group and I just moved it 1 carbon to the left. And by moving it 1 carbon to the left, I have another isomer of C6H14. Isomers have the same molecular formula, but the way that the atoms are structurally put together is different. So if I were to name this one, this would be 3-methylpentane. Now if I continue to move that methyl to the next carbon, if I look at that, the branching now has switched to be closer to the left side. So if I were to name that, it would be 2-methylpentane. So I can't continue to move that methyl group anywhere else because it will give me a structure that I already have drawn. So the next step says to now take 2 methyl groups and use them as branching and have a 4 carbon chain. So now I have my 4 carbon chain, and I can put my methyl groups on that 4 carbon chain. So I can put one here, and I can put one here on 2 separate carbons, and that would be named 2,3-dimethyl. and it would be a butane. So that would be 2,3-dimethylbutane. Now I could also take the methyl groups and I could put them on the same carbon. And by doing this, I now have a new isomer of hexane, or C6H14, and this would be called 2,2-dimethyl. I can't fit it on there, so we'll come down here, dimethylbutane. So if I were to look at how many isomers I could make of C6H14, that molecular formula, I have hexane, I have 2-methylpentane, 3-methylpentane, 2,3-dimethylbutane, and 2,2-dimethylbutane. So total, I have 5 isomers for C6H14. And again, isomers they have the same molecular formula, but their structures are different. And just a couple hints to check your work. Make sure that you name all of the isomers using the IUPAC system, which you just learned about in class. And all isomers will have different IUPAC names. And that is one way that you can check your work to make sure that you don't have any duplicate isomers. And for practice, I would like you to determine and draw the 9 isomers of heptane. So you're going to start with what the molecular formula is, and I'll give you a hint. You're going to start with heptane as one of the 9 isomers. Make sure that you name them, so go through the steps and name along the way. I'm going to pause the video, or you should pause the video so you can try to draw those 9 isomers, and then I will show you the answers after you're done. Okay, let's see how you did. Here are the first 7 isomers of heptane. So we have heptane, 2-methylhexane, 3-methylhexane. So we took the heptane, took a methyl off, and we formed the branching on hexane. We don't have any more isomers for hexane, so now we're going to take another methyl group off, and we're going to have a 5-carbon chain with 2 branches now. So 2,3-dimethylpentane, 2,4-dimethylpentane, 2,2-dimethylpentane, and 3,3-dimethylpentane. So those are the first 7. Hopefully you did okay on those, and now we're going to take another methyl group on, and I will show you the butanes on the next slide. And here are the last 2. We have 1 butane molecule with 3 methyl groups on, so 2,2,3-trimethylbutane. And then we'll go back to the pentane. There is one other pentane, and that is 3-ethylpentane. So I can put 2 of those methyl groups together to form an ethyl group, and we can form 3-ethylpentane. So hopefully you did okay on coming up with those 9 isomers for heptane, and that's it for this lesson.